Hi everyone. Let's start our fourth chapter, quadratic equations. A quadratic equation is a polynomial equation of degree 2 and it has two solutions. If I take 2x square plus 3x plus 7 is equal to 0. So now what is the highest degree of this equation? The highest degree will be 2. Whenever the highest degree is 2, then we can call it as a quadratic equation. It is a quadratic equation. If I take anything like x cube plus x square plus 6x plus 7 is equal to 0. For this, the highest degree is 3. So it is not a quadratic equation. It is not a quadratic equation, but it is a quadratic equation. Right. What is the standard form of the quadratic equation? Ax square x plus c equal to 0 and a must not be equal to 0. Nothing but if I take x plus 7 whereas 0x square is equal to 0, it will give x plus 7 only is equal to 0, right? Which is not equal to quadratic equation. So definitely the highest degree must be 2 only. So you can give example as this one. 2x square plus 3x plus 7 is equal to 0. This is our example for this equation. Methods to solve quadratic equations. Using two methods, we can solve the quadratic equation. First method is factorization method and second method is using a formula, quadratic formula. We have a formula, so we can use that for solving the given quadratic equation. Let us see the factorization method first. We have already used the factorization method in our previous lesson. So, the quotient of x square and the constant. Multiply the quotient of x square. The quotient of x square is 1 and the constant is 6. 1 into 6 is equal to 6. Now you have to find out the factors of the 6, that is 2 and 3. So directly you can take 2 and 3 from this. 2 plus 3 is equal to 5 only, right? You need to get the middle term, the quotient of middle term when you add them or when you, anything is fine. Whether you add or you subtract, you need to get the middle one, the quotient of x. Let us write this as x square plus 2x plus 3x plus 6 is equal to 0. We have already solved this method in our previous chapters. So from these two and these two, take x as common, x plus 2. And in these two, if you take 3 as common, again x plus 2 is equal to 0. Now x plus 2 is common, x plus 3. Take it out, which is equal to 0. Now x plus 2 is equal to 0 and x plus 3 is also equal to 0. X is equal to minus 2 and x is also equal to minus 3. A quadratic equation definitely have two solutions, right? Definitely have two solutions and it is in the form of ax square plus bx plus c, right? So here x is equal to minus 2 and x is equal to minus 3. X is equal to minus 2 as well as minus 3. Now these two are roots for this equation. These we called as roots of x square plus 5x plus 6 is equal to 0. This is our first method. By using this particular method, we can solve the given quadratic equation. The next method is using quadratic formula. So we already know the standard form of the quadratic equation is ax square plus bx plus c is equal to 0. This is our standard form. So using the quadratic formula, this is the quadratic formula. Using the quadratic formula, we can easily solve the quadratic equation, right? So if you take this, consider the same example as we did in the factorization method, which is x square plus 5x plus 6 is equal to 0. Our discriminant value is b square minus 4ac, and this quadratic formula, this is a main formula, and this we called as discriminant. This is discriminant. So this we called as discriminant, and this is main formula. Right? Now, what are the nature of the roots? We can also tell the nature of the roots by solving only the discriminant, by using only the discriminant. So if this discriminant value is greater than 0, two distinct real roots will come. So distinct real roots means definitely two roots will come, and those two roots are different. We will get different roots here. And in the down, if discriminant is equal to 0, two roots will come, but two roots are same. Equal roots will come. If discriminant is less than 0, no roots will come. 0 roots. No roots will come. Let us solve. Here you are seeing x square plus 5x plus 6 is equal to 0. What is the a value? A is equal to 1, b is equal to 5, and c is equal to 6. When you compare it with the ax square plus bx plus c is equal to 0, a is equal to 1 and b is equal to 5 and c is equal to 6. Now what is the formula to finding the roots? X is equal to minus b minus 5 plus or minus square root of b square 5 square minus 4 into ac. A into c. From the equation divided by 2 into a. Whereas x is equal to minus 5 plus or minus square root of 25 minus 4 6 are 24 divided by 2 minus 5 plus or minus square root of 25 minus 24 is 1 divided by 2, which is equal to minus 5 by 2 plus or minus 1. Now minus 5 plus 1 by 2 or minus 5 minus 1 by 2, which is equal to minus 5 nothing but minus 4 by 2 or minus 6 by 2. 2 1s are 2 2s are 2 1s are and 2 3s are. So the roots are x is equal to minus 2 and minus 3. The same roots came like when we solved the same quadratic equation using the factorization method. This carefully, two roots came and two roots are different. So we can say the discriminant value is greater than 0. Let us check whether the discriminant value b square minus 4ac is greater than 0 or not. What is b square? 5 square minus 4 into ac, 1 into 6. 25, which is equal to 25 minus 24, which is equal to 1, greater than 0. Hence proved. The nature of roots are real and distinct. That's it for the introduction of 4th chapter, quadratic equations. Let's meet in the next video for exercise 4.1. Thank you.